Every smartphone begins in research labs, where engineers and designers collaborate for months creating the perfect device blueprint.
Engineers meticulously design internal layouts for battery, camera modules, motherboard, and advanced cooling systems within millimeters.
Teams optimize operating systems for hardware performance, ensuring smooth integration between software features and components. Thousands of simulations test durability, heat management, signal strength, and battery life under various extreme conditions.
Inside the giant mega factory, production begins with raw materials sourced from around the world. Aluminum, stainless steel, glass sheets, silicon wafers, and lithium compounds arrive ready for smartphone manufacturing.
Materials undergo rigorous inspection for purity and quality, because even smallest defects can affect final performance.
Materials are stored in climate-controlled warehouses, organized by type and production schedule for manufacturing.
Processor manufacturing begins in ultra-clean semiconductor fabs, the most advanced facilities in the world.
Silicon wafers are polished to atomic-level smoothness, creating the foundation for billions of microscopic transistors.
Photolithography machines use ultraviolet light to carve microscopic circuits smaller than 5 nanometers onto silicon. Modern processors contain billions of transistors, each smaller than a virus, working together at incredible speeds.
Processes add insulating and conducting layers, building up complex three-dimensional structures on the wafer. Each chip on the wafer undergoes electronic testing to identify working processors before cutting and packaging.
Working chips are carefully cut from wafers using diamond saws, then packaged with protective casings.
Glass sheets undergo chemical strengthening through ion exchange, making them scratch-resistant and incredibly durable.
OLED layers are applied in vacuum chambers, creating organic light-emitting pixels for vibrant colors and deep blacks.
Each pixel contains red, green, and blue subpixels that emit light individually for perfect color reproduction.
Touch sensors are embedded directly into display layers using in-cell technology, making screens thinner and responsive.
Each display undergoes extensive testing for brightness uniformity, color accuracy, touch responsiveness, and dead pixels. Electrode preparation involves coating lithium compounds and graphite onto metal foils with micrometer precision thickness.
Electrodes are layered with porous separators and rolled precisely to maximize energy density while maintaining safety. Electrode assemblies are placed into protective casings. Then, electrolyte solution is injected in controlled atmosphere.
Batteries are sealed hermetically, preventing leakage, then charged for first time in conditioning formation process.
Rigorous safety testing includes overheating, puncture resistance, overcharging, and short-circuit tests for every battery.
Camera manufacturing requires extreme precision in dust-free environments where even tiny particles ruin image quality. Multiple lens elements are molded to exact specifications and stacked in precise alignment inside camera barrels. Image sensors containing millions of light-sensitive pixels are mounted on circuit boards and calibrated meticulously.
Optical stabilization units with tiny motors and gyroscopes detect movement and adjust lens position thousands times per second.
Each camera module undergoes optical testing for focus accuracy, color reproduction, and performance under different lighting.
The SMT line is the most advanced area, where high-speed robots place over 30,000 components hourly.
Solder paste containing tiny solder balls is applied through stencils with extreme precision onto circuit boards.
Pick-and-place robots use computer vision to position components smaller than sand grains with micrometer accuracy. Processor chips, memory chips, and power management units are mounted alongside hundreds of other critical components. Boards pass through reflow ovens where controlled heating melts solder, creating permanent electrical and mechanical connections.
X-ray machines detect hidden defects like solder bridges, insufficient solder, or misaligned chips beneath other components.
Each motherboard is powered up and tested electronically, ensuring all circuits function correctly before assembly. CNC machines carve solid aluminum blocks into phone frames with micrometer precision using diamond-tipped cutting tools.
Multi-axis machines create exact holes for buttons, charging ports, camera openings, and speaker grills perfectly.
Anodizing processes add beautiful colors while increasing surface hardness and corrosion resistance for long-lasting durability.
Glass back panels are cut from chemically strengthened sheets, then edges polished to smooth perfection. Logos and designs are precisely printed on inner glass surfaces using specialized techniques for protection.
Coating layers add color, texture, scratch resistance, and oleophobic properties, preventing fingerprints on glass. Assembly brings all components together, where robots and skilled workers collaborate, building complete smartphones.
Motherboards are installed into frames and secured with precision torque-controlled screws, preventing damage from over-tightening.
Batteries are connected through precision connectors and secured with strong adhesive, ensuring stable power supply.
Display assembly requires careful alignment and bonding using UV-cured adhesive, creating strong yet potentially repairable bonds. Back covers are attached with carefully positioned rubber gaskets and seals, providing water resistance protection. The smartphone powers on for the first time, an exciting moment where the device comes alive.
Operating systems are installed from master images, including pre-installed applications and manufacturer customizations for users.
Firmware for components is updated to latest versions. Security patches and encryption keys are installed.
Screen is calibrated for responsiveness and accuracy across entire surface, ensuring perfect touch detection everywhere.
Camera systems undergo calibration for focus accuracy, color balance, and image stabilization, ensuring professional photo
Audio
quality.
systems are tested and tuned for speaker output, microphone recording quality, and noise cancellation. Display color profiles are loaded and verified using precision colorimeters, ensuring accurate color reproduction standards.
Wireless systems, including Wi-Fi, Bluetooth, and cellular radios, are tested for proper function across frequencies. Every smartphone must pass strict quality checks before approval, ensuring only perfect devices reach consumers. Drop tests from various heights onto different surfaces ensure phones survive real-world accidents and impacts. Tumble tests simulate phones being dropped repeatedly, verifying structural integrity and component security under stress.
Endurance tests involve pressing each button thousands of times, ensuring long-term reliability and responsiveness.
Tests repeatedly insert and remove cables thousands of times, verifying connection durability and contact reliability.
Camera testing captures photos and videos under various lighting conditions, comparing results to reference quality standards.
Display testing verifies color accuracy, brightness uniformity, viewing angles, and checks for dead pixels meticulously.
Battery testing ensures proper charging, discharge rates, and power management system communication work flawlessly together.
Wireless connectivity is tested for all supported bands and protocols under simulated different network conditions.
Water resistance is verified by immersing phones in controlled water conditions, ensuring advertised protection ratings.
Failing any test are sent for repair or disassembled for parts recycling, maintaining sustainability.
Improved smartphones move to packaging, where protective films are applied, preventing scratches during shipping and handling.
Accessories including chargers, USB cables, SIM ejector tools, and documentation are gathered for each package.
Phones and accessories are placed into premium retail boxes precisely designed to hold everything securely and attractively. Automated systems verify each box contains correct items, using weight sensors and vision systems reading serial numbers.
Boxes are sealed with tamper-evident seals or shrink wrap, ensuring product security until customer purchase. Labels with regulatory information, barcodes, and serial numbers are applied for tracking and compliance purposes. Final inspection checks each sealed box for cosmetic damage, proper sealing, and correct labeling before approval.
Each box is scanned into inventory systems, creating complete digital records tracking that specific device.
Boxed smartphones are packed into shipping cartons containing multiple units for efficient warehouse storage and transportation.
Cartons are palletized for efficient warehouse storage, shipping logistics, and systematic inventory management throughout distribution. Sophisticated logistics systems track each shipment from factory to destination using RFID tags and databases. Temperature and humidity are controlled during shipping, preventing damage, with insurance and security protecting valuable cargo.
From distribution points, smartphones reach retail stores and ship directly to customers, completing the global journey.
Your smartphone represents thousands of workers, hundreds of robots, components from dozens of countries in perfect harmony.